picking methods. This is the area in which advances in technology have transformed the picking operation and improved the accuracy and productivity significantly. The introduction of barcoding, voice technology, and pick-by-light systems is not only improving warehouse picking operations, but also producing an acceptable return on investment. Now let's talk about some picking methods that are currently in use in today's warehouses. A paper pick list will normally detail the order number, location, product code, description, and quantity. If utilizing a warehouse management system, each product line will be shown in sequence, enabling the picker to travel the most efficient way around the warehouse and ending up as close to the dispatch bay as possible. The operator, however, free to choose a different route if it is felt that it is more direct. Any discrepancies are written on the pick list. When the list is returned to the supervisor, the discrepancies should be checked and alternative locations provided if there are shortages. Afterwards, the details from the pick list are entered manually into the system. This can lead to errors if the writing is illegible, or there is confusion over the way a number is written. Paper picking requires little investment, however. It can have low accuracy and may require order validation. Pick by label. In this system, pick lists are a series of labels on a sheet which are printed in pick order. The picker attaches a label to each item, picks and returns any unused labels in the supervisor's office. Any discrepancies are checked immediately, and additional labels printed if the stock is available somewhere else in the warehouse. This can eliminate a step of the dispatch area as address labels are already attached. This manual forms of operations and low levels of productivity and accuracy have led to an increase in the use of technology within the warehouse. The use of pick-by-voice technology is gaining ground in warehouses globally, particularly for order picking, although other processes such as cycle counting, put away, and replenishment also utilize the system. Many companies are moving directly from paper picking to voice and bypassing barcode scanning. Operators are issued with a headset, a microphone, together with a small terminal that is attached to a belt or can be worn on the wrist. The warehouse management system sends messages to the computer via radio frequency, utilizing transmitters installed throughout the warehouse, and the messages are converted into voice commands. The operator also uses voice to communicate back to the system. Here is a short list of benefits of pick-by-voice system. Increase the accuracy and productivity, reduction in paper usage, reduction of errors, improved safety, reduction in damage, real-time stock updates, reduced training times, accommodating diverse workforce, easy to integrate, reduction in employee turnover, and a quick return on investment. This system has become prevalent in the food service and grocery retail sector. It is particularly suitable for both chilled and frozen environments where gloves hamper the use of radio data terminals and paper, while the hands-free aspect of the system have major disadvantages over paper pick lists and labels and barcode scanning. As can be seen in this picture, voice can eliminate a number of steps in the pick process, leading to an increased productivity and accuracy. In order to calculate the benefits, you need to measure productivity levels before and after implementation. Increases in productivity can be measured in terms of the average cases per hour picked by each worker. Take, for example, the cases picked per day divided by hours per day work, divided by the number of pickers. Here in the example, if you have 36,000 cases divided by 7.5 hours per day, divided by 35 operators, and we receive 137 cases per hour per operator, at 10% productivity gain would raise the cases per hour to 151. To calculate the reduction in operators, we use the same equation, and we see now that we will only need 32 operators. This means that 3 fewer operators are needed with a switch to voice direct selection based on a 10% improvement in productivity. Further, savings can be made in terms of stationery, labor involved, in administrative tasks, the training of personnel, improved safety, and so on. Time to full productivity for a new worker using scanning methods is typically 2 to 3 weeks. With voice, it can be as little as 3 to 4 days. More recently, picking can also be conducted via pick-to-vision through augmented reality. AR vision picking is relatively new. Now let's talk about barcode scanning. A barcode consists of a series of vertical bars at varying width that represent letters, numbers, and other symbols. Barcodes are used to identify products, locations in the warehouse, containers, serial, and batch numbers. As with many areas of supply chain logistics, there is no conformity and thus no universal barcode. This can make it difficult to transfer products between companies and countries. The main barcode standards are EAN8, EAN13, and Code 128. Recent developments include two-dimensional barcodes, the advantages being that you can store a greater amount of data within a much smaller space. Barcode readers come in many different forms. They can be handheld, static, truck-mounted, or wearable. Data can be read, stored in the scanner, and then downloaded by attaching the scanner to the computer by USB, or also can be transferred in real time through radio frequency or cloud computing. Barcode scanning utilizing handheld scanners with real-time data transmission has made data collection faster and more accurate in today's warehouse environment. It has also increased productivity by ensuring that operators don't have to return to the office for instructions each time they complete the task. The instructions are on screen in the form of text, with the operator scrolls through the advances by choosing the specific commands. However, barcode scanning with handheld devices has some drawbacks. These include having to set down the reader while tasks are carried out or struggling to hold the unit and carry out the task at the same time. Errors tend to occur when using handheld scanners if they are holstered or put down on the surface. This movement can cause the picker to pick from the wrong location or miscount the items. A recent advance in this area includes the introduction of hands-free wearable computers that enable the operator to handle products with both hands as opposed to having to hold the barcode scanner, paper pick lists, or labels. A wireless-enabled wearable computer allows operators to receive instructions in real time, scan barcodes, enter data, and transmit in real time. By using wearable computers, one task is eliminated, thus making the big process quicker and potentially reducing errors, productivity, and accuracy improvements can lead to substantial savings. These systems are also providing benefits in other areas, including improved customer service, decreased training time, reduction in damages and accidents, increased employee satisfaction. One of the main disadvantages of barcodes is their potential to be damaged and thus making reading difficult or potentially inaccurate. RFID, or radio frequency identification, is a means of uniquely identifying an item using radio waves. Data is exchanged between tags and readers, and depending on the frequency, may or may not require a line of sight. Common uses in today's world include the library books, toll passes, and access ID cards. The system enables the simultaneous reading of multiple items as opposed to barcodes, which need to be read individually. There are two types of RFID tags. Passive, they have no power source, limited data storage capacity, are read-only, and have a limited read range. The other RFID, the active ones, they have their own power source, have a large data storage capacity, have a read-write capability, and are readable from a greater distance. Active tags have a higher capacity and can have their item status updated once the task has been completed. They have a shorter writing range than the reading range, and the internal power source is likely to burn out within 5 to 10 years. The difficulty faced by proponents of RFID is that barcodes are very cheap to produce and remain an accurate and cost-effective method for identification. The cost of operating an RFID system will vary tremendously depending on the application, the size of installation, the frequencies, and the quantity of tags purchased. Next, order picking methods like pick to light or pick by a light use a light indicator, LED or LCD modules mounted on shelving, flow racks, pallet racks, or other storage locations. The system tends to be used with zone picking. To begin the process, an operator scans a barcode on an arriving pick, tote, or a shipping carton, which denotes the next order number to be picked. This communicates the system that the operator is ready to pick. The system then sends a message to the zone in which the operator is stationed, and all locations for that particular order light up at once. A digital display tells the operators the quantity to pick. Once this has been done, the operator turns the light off to confirm the pick and then move on to the next location until all of the pick in the area is completed. All information is exchanged in real time with enterprise resource planning systems. The ERP or warehouse management systems, in other words. Unlike scanning and voice picking, which are sequential in nature, all locations are indicated to the operator at the same time. This means that the operator can choose the best pick path. And lastly, put to light. This is a system particularly prevalent in retail store replenishment operations. The warehouse management system will consolidate all of the store orders for a particular group of stores, and the system needs to ensure that each group of stores has similar volumes where possible. Depending on the daily volume, staff can increase or decrease the number of locations that they will look after. Once the SKU has arrived at the put station, the operator scans each item and a flashlight light displays each location, indicating which containers require that product and how many items are required. Once confirmed, you put the results are uploaded to the system in real time to update the warehouse management system. There is a file attached to this lecture where you can see the advantages and disadvantages of different order picking systems. Maintaining high warehouse productivity to meet growing needs of customers is an essential task for logistics. Augmented reality or AR vision picking is an innovative way to increase flexibility of your supply chain using augmented reality to optimize your warehouse operations. Let's look. What are the main benefits of AR vision picking technology? First of all, minimal training and onboarding time required for operators, since interfaces of AR applications are intuitive, user-friendly, and require minimum interactions. Vision picking is a hands-free technology that provides maximum convenience for users. AR smart glasses are comfortable to wear and do not obstruct the view of the user. With the help of vision picking technology, it is possible to build optimal operator routes, reducing the time for moving around the warehouse facilities. Fully automated tracking of items in augmented reality apps maintains the accuracy and relevancy of inventory data. Error-free vision picking improves quality control in your warehouse. With the help of AR applications, you can detect the employee's location throughout the warehouse and quickly assess productivity of any employee. The main limitations of the vision picking technology are concerned with hardware as well as privacy of the employee. Despite the significant development of AR smart glasses in the past few years, some aspects still need improvement. First of all is speech recognition. Microphones built in within the AR smart glasses provide satisfactory speech recognition, but the headset with a noise-canceling microphone located near the user's mouth provides higher recognition accuracy. Speech recognition accuracy is critical in real working conditions of the warehouse with a high level of noise. Imperfect noise canceling and recognition accuracy may lead to errors or inability to recognize the user's speech. With barcode scanning, AR smart glasses provide image-based barcode reading with the built-in camera. Image-based scanning is slower and less accurate than traditional barcode scanning. Thus, modern AR smart glass applications use external barcode scanners to speed up processing. Another one is battery life. Intensive use of AR smart glasses quickly drain the battery. Once the battery is charged, there's not enough for the full shift. This can be problematic. Therefore, some manufacturers of AR smart glasses give the opportunity to connect them to an external battery pack that you can wear or replace a battery. Of course, these measures are not convenient. Therefore, manufacturers are looking for ways to reduce the energy consumption of smart glasses and equip them with more powerful batteries to extend the working time on one charge.